Hi all, hi everyone. Welcome to our day 11 of DevOps, 100 days of DevOps. So happy Guru Parab to all of you out there. Uh, Guru Nanak Jayanti or Guru Parab, whichever you prefer. So happy Guru Parab, happy Guru Nanak Jayanti to all of you today. So let's get started. Today we'll be uncovering another tool which is essential for DevOps. Okay, another tool and technology as well. We can say, which is, wait a minute, where did it go? Yeah, containerization. Okay, containerization and Docker. So containerization is a very essential technology that is required, that is that move the DevOps world by leaps and bounds. Okay, so let's get started with that. First of all, let's recap over what are uh, virtualization first. Okay, so earlier we have discussed about virtualization. Suppose this is a piece of hardware. This is a hardware. Hardware means there is some kind of like CPU, memory, okay, and storage, network devices available. Okay, everything in this. So in this hardware, before virtualization, let me just CPU and memory, storage, okay, peripherals. So there are some of these are some of the tools, okay, that we have in our virtualization part. In hardware generally we have these tools, okay, CPU, memory, storage, and this is a hardware, a device, okay, physical server. So what is the usage of this physical server is to host some kind of operating system. Earlier it was only one operating system at a time. Okay, then comes the virtualization. Let me introduce another layer here. This is the virtualization. Hypervisor, we can say, hypervisor. Okay, so what does virtualization do? Virtualization basically allows us to install multiple OSs on our system, on our hardware. Okay, there are two types of hypervisor. Hypervisor is basically an OS that allows you to run other OS on top of that. Okay, that virtualizes the hardware. Just note my words. It virtualizes the hardware like CPU, memory, storage. It provides a layer which is called hypervisor here, hypervisor, and it enables a physical machine to it enables a physical machine to just copy these components and creates a virtual machine with that. Okay, so these are with the help of virtualization we can spin up multiple other OSs on top of a hardware. So there are basically two types of hypervisor, type 1 and type 2. Type 1 is basically like to be installed directly on a hardware. Okay, and type 2 is like there are some of the examples like which one, VMware ESXi server. It is a type 1 hypervisor. It can directly be installed on a bare metal. Bare metal means this physical machine directly. Okay, other require some kind of OS in between. So those are called like here if I add another layer of an OS, okay, on top of this OS OS on top of this. So it creates it is called type 2 hypervisor. Okay, so that's how it is. Some of the examples of type 2 hypervisors are the one that we are currently using, virtual machine, this VirtualBox, Oracle VirtualBox, and there is VMware. Okay, so some of them are these are the type 2 hypervisors. Then going back to our utilization. So if I have to create a here, let me just put it in words. Virtualization is used to virtualize the hardware. Okay, this is the basic definition of virtualization. What does virtualization do? It virtualizes the hardware. Okay, hardware to be precise. So but in virtualization, like I have created these many virtual machines. If I have to create another, this is a Ubuntu machine. Okay, this is Red Hat Linux, RHL Linux, Parrot Linux, and this Kali Linux. So there are multiple different virtual machines. So if I have to create another virtual machine, it will take me some time. Okay, however, there is one more technology that comes in virtualization part, which has made, since we all know that DevOps is all about agility. Okay, agility, automation, quick delivery, less time to market. Okay, we have discussed all of this in on day one. Okay, so there is another technology, containerization, is used to virtualize OS, operating system. Okay, Here it is used to virtualize hardware. This one is used to virtualize the operating system. So this is the basic difference between virtualization and containerization. Okay, so let me just go quickly. I think my machine is already running. It is connected. Yeah. So earlier we have seen that there is some kind there is this Apache we have installed on this server. Okay, yeah, in previous sessions. Let me just open my Mozilla. Yes, Mozilla is here. So if I just open, okay, one more thing I need to check, which was cat/etc/hosts. Yeah, so here this is our domain name, which we have assigned to this particular IP. HTTP. So yeah, our Apache server is running right now. So what happens here is, if we install any particular software, suppose Apache is also running in this, it is hosting some kind of web browser website on web application on it. Then there is a database also in this, file server, some kind of object storage, or it is installed in this particular server. So what will happen here? It might take some if this particular instance means this particular VM, okay, virtual machine gets crashed. So what will happen? Database also gets crashed, then file server also gets crashed, some kind of backend which is running like some AI or some kind of application, some Python backend or Python API, if it is running on this particular machine, that's also gets crashed. So what is the how can we fix that? So virtualization is itself is created to provide isolation. However, it is not it takes so much time. Okay, it takes so much time to spin up another instance another instance of a virtual machine. So that's why there is another thing, another technology that came in picture, which is called containerization. So let me just a very popular tool that we use for containerization is Docker. I don't think Docker is currently installed in my system. Okay, Docker is not installed. But one more thing, first of all, I'll just IF config. So there are these two network interfaces currently available for me on this particular VM. Okay, for now, systems sudo systemctl status. Oh yeah, status. Sorry, status. Oh, sysctl system ctl Apache to service. Okay, so this Apache server is currently running. So for now, I'll be turning it off. Okay. Stop is another command, another option that we can use for to turning a service off. So there are two things. Okay, here if you can see, preset enabled. Okay, service enabled. This service is enabled means whenever I restart this particular server, okay, it automatically start this particular service automatically. Okay, so there is first of all, let's just check for the status here. So here service is enabled, but right now it is inactive. Okay, we have closed this service, stop the Apache HTTP server. Here you can see. Let's just disable it. Okay, yeah, so it is systemd services multiple user target one. So we have removed this particular file. Okay, Apache service is currently removed from this this target user target ones, multi-user target ones. So this file is removed. Okay, so what is the result of this particular thing is synchronized state Apache sys service this executing disable. Okay, first let's just check. So here you can see service is disabled. Okay, vendor preset enabled means by default when we install any particular server, if the vendor preset is enabled, so it will at the time of install itself, it will enable the service. However, we have disabled it. So even if we can restart the particular VM, let me just do that. So first of all, I'll just show you what is happening. Yeah, sorry. Let me just enable it first. Enable. Okay, created this particular file libsystemd. Okay, here this file is created. Okay, it has copied this particular file into this target, and it is enabled. Here you can see it is enabled, service is enabled. So if I reboot this, permission denied sudo. Okay, now my machine is rebooted. If I refresh this page, or let's just talk about the IP 192.168. 1.9. So server not found. Okay, server not found, it is showing me. I think it is restarted, connection refused. Okay, it is restarted. If I rerun it, okay, my website is again back. It is checking. Website is back again. Okay, I'll just put in my, okay, I am logged in. Let's just check sudo systemctl status apache 2. Oops, I have to add my password. Yeah, it is active again. Okay, uh, earlier we have disabled it, we have sorry, we have stopped it, but it somehow started again. So let's just disable it. Disable. Okay, right now service is active and running. However, the service status is disabled. So let's just reboot again. Sudo reboot, enter, refresh. Yeah, so our this server is not loading. Okay, so let's just see why. We know why actually. We have disabled the Apache server, so it is not able, it is unable to start on its own. Okay, so here we can see and inactive, dead. It does not show if we have stopped it earlier, because earlier if we can see in previous logs, it has said stopped at this time, inactive, dead. Okay, so it shows the command right now there is nothing. Okay, because it does not have, it is disabled, so at the time of start it does not get started. Okay, sorry, I was, please zoom in. Actually I forgot to do that. So yeah, so this is a add-on for this. So let's just here docker command is not installed right now in my system. So what I'll be doing is, this is the command, that's why I love Ubuntu. Okay, it provides you, so docker.io, it has some other additional like lib, this bridge utils, container d, we'll see what is container d mean, then dns root data, dns mask base, docker.io, and ubuntu fan, run c and container d are most crucial parts of docker. Okay, docker.io. So let's just get started. Okay, it is installing docker right now. So in the meanwhile, I'll just brief you about container d, and just a moment. So here we have installed docker. Here you can see docker hyphen v is available. This is the docker version. So docker is a software, a containerization tool that is developed in go language. Okay, so here are some key points. So this is called the docker CLI, in which you can put the command. Okay, then there is sudo system ctl status docker. I think docker socket, docker service is one thing, and docker service is dead. Docker socket, it is also inactive as of now. Vendor preset is enabled, so at the time when we start this particular restart this server, it will be enabled. Okay, then I'll just show you about container. Yes, container d service, container d. Okay, it is also disabled. Run c, run c. Okay, run c is not a thing, so that is fine. So we have docker CLI that takes our command. Okay, then there is docker daemon, which is which runs in background. Okay, it actually executes those commands that we have provided using docker CLI. Okay, and it is daemon through docker CLI use RESTful API, and that talks with docker daemon. Okay, then docker daemon that listens to docker API request, and sorry, manages images, container, network volume. It is just like a manager. Okay, then docker daemon is the one that communicates with container d. Okay, container d to manage the lifecycle. What is container d? Container d does, so this container d is a lightweight high performance container runtime. It is the runtime that actually runs those container. Okay, pulling images, creating container, handling storage, network. So let's just say docker CLI is our reception. Okay, docker CLI is our, let me just explain in this terms. So docker, we have docker with us. Okay, this is docker. We have the docker CLI. Okay, this is like reception desk, reception or order taking part. Sorry, reception. Okay, what it will do, there is a manager, we can say, which is called Docker daemon. Docker daemon. Okay, so how do they connect? It is a daemon, means it is like a manager. Okay, manager. It talks over RESTful APIs. Okay, so these two are connected. Then there is the behind the scene is run by, so Docker CLI takes the command, takes the input from the user, okay, user interface, okay, and Docker daemon receives it through REST API manager. Okay, then there is or it, let's just say it is in let's just take hotel, it is some kind of restaurant. Okay, so this is the waiter, this is a manager, or that particular desk that manages the uh, manages, I think, I'm not sure what is called, some kind of table or a window where where the waiter tells the order. And then there is container D. Okay, container D is basically the let's say here, this is container D. Container D manages the process. Okay, pulling images, creating like chef's assistant kind of. Okay, creating and managing container instances, handling storage network, run as long as long live daemon. Okay, as long so till the time this particular is running, container D is also running. Okay, then there is it provides an API for the Docker daemon to interact with low level container management. Then comes the runc. Runc is also a command line tool. Okay, runc is similar to this Docker CLI, directly responsible for creating and running the container. So this part handles the logistic. Okay, sorry. So this part, container D manages the logistic part. Okay, heavy hauling is done by container D, and runc is basically runc is where did it go? Any creative, yeah, let me say this. Okay, so runc is another command line tool. We can if we don't want to use Docker CLI, we can directly use runc as a command. So it also talks with this container D. Okay, so it manages runc is a command line tool. It is there is one body that governs this container initiative. Okay, open container initiative, OCI. Okay, directly responsible for creating running containers on the host system using Linux namespaces. Okay, then this runc is basically talking to the hardware, or we can say kernel of the OS. Okay, works at an even lower level than container D. This part. Okay, even lower level than container D. So that's how runc is working. Runc is actually doing like this is head chef over here, container D. So it tells everything like chef, manager, or say it is like supervisor. And here is the worker. I hope you understand these analogies. Okay, so these four things comes together and build the Docker. Okay, these four things are so let's just get started. So these are our workforce that is running behind the containerization. Okay, so let's just get started with our container. So if I suppose sudo, if I just run docker ps, so it will say your daemon is not running. Okay, your Docker daemon is not running, so which we have seen right now. Okay, Docker service, then Docker socket. This Docker socket is responsible for the API connectivity. Then there is container D, which is the daemon. Then runc is basically the CLI tool. So if I can see runc -h, so here you can create delete containers using runc itself. Okay, it also, yeah, where container ID, open container initiative. Let me just check if I can run C without starting the daemon, if I can create something. Run C, run bundle. Wait a minute, I'm not familiar with run C commands, so let's Google it. Run C sheet. I actually haven't used it in so much of time. Run C container D Oddman build. No, not this one. Run C Run C command cheat sheet. Okay, I think we have to use that particular page itself. No worries with that. This we already we have this main page. Run C run bundle to run a new instance of a container. Let's just run it. Okay, no worries with that. Run C kill execute create delete. I don't think it will start execute user defined process in a created container. Run C run hello. Okay, run C failed JSON config JSON not found. So there are multiple different things that runs behind this. So what we'll do here is, so run C is also not working. We'll start this socket. Okay, let's just see how what it has done. It is active. Okay, Docker service triggered Docker service. It has triggered Docker service. Okay, let's just see status Docker service. Docker service is also triggered by Docker socket. Docker service is inactive. Let's just start, or maybe let's just check it in some time. It has already been triggered. Or status container D. Container D is inactive. We can start this. Start container D. Status, it has been started. Started container D container runtime. It has been okay. So we can use this. Then there is, let's check if our Docker service is up. Manually start it. So Docker service is also running. So I think there are these. So there is one thing that run C can create run the container runtime, create and run the containers. Okay, but it is unable to pull the container images and others. So here I think we haven't found anything. It can start, update, check, spec, run, resume, restore. PS is for displaying the processes. Then pause, kill a container. Okay, kill a container or containerized process. Then execute new process inside the container which is already running. Yeah, I don't see here the pull command. So that's how Docker leverages the functionality of run C. Then containerd comes as a helper that will manage that will like does the pull push anything it want, and then it will work accordingly. Okay, and then this Docker d1 is like manager, so it manages everything, all the container what to do, and Docker CLI is the particular like reception desk for our system. So let's just see Docker ps means okay. Oh, permission denied, no issues with that. Sudo, yeah. So now currently there is nothing available. So let's just see Docker -h. What do we have here? So these are the management commands. These are common commands like docker run, docker exec, docker ps, build, pull, push, image, login, logout, search, version, info, anything. Okay, then there is, I think, inspect command is also there. Inspect, docker inspect. Inspect is basically, and these are builder, container, context, image, manifest, network, plugin, volume. All of these are like the management commands. Okay, they have integrated swarm as well. Okay, inspect, yeah. Return low level information on docker object. So first of all, let's just docker inspect. What do we have here? Okay, we need to specify a particular docker object. So here docker inspect requires a particular object to inspect on. Let's just see docker network. Yeah, network is the very basic thing. Network, that yeah, network connect, create, disconnect, inspect, ls. Let's just see ls. Okay, sudo. So there are these three networks which are available. Let's just discuss about we'll be discussing on our containerization journey on these networks. So this is bridged, host, and none. So these three networks are created. So let's just see. Earlier we have seen our if config. Okay, if config, it has created one more virtualized network card. Okay, here this is the network card. So this is particularly created for, like, here you can see it has created a subnet in a network in itself. It is isolated from this. Okay, so that's how Docker can be used. Okay, Docker provides a isolation. So any container that let's just forget about it and let's just create a container. So sudo docker run which one? dit. To D means to detached mode, it means to interactive mode. I is interactive and T is for terminal. So we can anyhow -h, we can docker run help. Yeah, so here you can see D data is mode, run container in the background and print the container ID. Okay. Then there is -a -I interactive mode, keep standard input open. Then there is -t tty, allocate as sudo tty. Okay, what is tty? It is like a terminal, a shell kind, a user interface for that. Okay, so if first of all let's just run docker run busybox busybox. Okay, so right now I do not have this busybox is right now pulling. Okay, this container image is right now pulling. So what does it do? It has been created. Okay, busybox, it has been created. A newer images. How can we check? Docker ps command is for listing. It has been created or what? Okay, docker run -it. Yeah, so it provides us with a shell. Who am I? Root. Okay, host name, this is the host name, and if I think it is deleted. Yeah, it is deleted. No worries with that. We can create another one. Docker run or docker, there is one more thing, docker ps -a. So it shows all the containers that has been, so it has been exited. Okay, this busybox is exited. Busybox, these are the randomly selected name like festive, leavet, flamboyant, blackburn, inspiring, galileo. These are the name of those containers. Let's just see, let's just run nginx. So right now in my system, nginx, if you can see, nginx is not installed. Okay, so how can I run this? So this is how you can easily run any of the container. Okay, like run CentOS, and I'll just provide it because I want it to be dit. Yeah, CentOS. Let's see. CentOS is not available locally, so it is right now installing it. So it is very fast. It just, if it checks if there is any particular image, what is image, will understand about it. So image is like an ISO file. Okay, here we have installed a particular operating system over here. So any OS has any OS requires a particular ISO. ISO is a set of like it is a set of commands that it is basically the storage. Okay, like some image or a CD from where you can install some application, CD or this thumb drive. Okay, so ISO, like we have created this particular Ubuntu image, this Ubuntu machine. So it is a bundle of softwares that is used to launch this OS. So similarly, image is a bundle of like bundle of program that is used to launch a container. Okay, so it is very fast. Containerization is very fast over the virtualization. It is like it takes not it does not take even a minute to run a container if the image is available. Within seconds we can say. Yeah, so this is how the containerization is very fast. Okay, we have let's just get inside the container. So what is the command for that? Sudo docker ps. Yeah, so CentOS is running right now. This is the container ID that we have seen, and here also earlier we have hostname we have run here. So this is the container ID used as hostname. So we can do container ID or by name. Docker, there is this command docker exec to execute -it, which is interactive terminal, interactive tty actually. Then container ID, and which command do we want to run? Okay, let's just say sh command. Okay, here is the shell. We are right now inside the CentOS machine. How can we verify that? We have seen /etc/os release. Here, this is a CentOS machine. Okay, RHEL, Fedora, ID like platform. So this is how you can run it. So it is very fast. It is very convenient. Similarly, if you want any particular environment like Python, don't.js, or I'll just remove it. How can I, like, docker ps -a? There are so many containers right now. How can I stop this? This is currently up for 22 minutes. So there is this command sudo docker stop docker stop command. Then select the container ID or name. Also name can also be used as. So here docker ps -a, everyone is exited 24 minute 24 25 2 seconds ago. Then I have to remove any particular container. So how would I remove this? Again, name, copy the take the name or container ID of this particular container. Sudo docker rm, since it is stopped. So until, yeah, it is deleted. And if you have to remove all the containers, I think rm-a. So there are these three containers, rm help -f rm-a. What was that command? Rm. Okay, no problem. Docker ps -a, we can get this -q, only the ID, then awk or where is it? anyway, there is this awk, I think awk, or is I can use another format. Here we can see no container right now available. So that's how you can easily create and destroy the multiple OS environments, and all of them are completely isolated. So let's just dig deeper into the networking part. Yeah, so let me just introduce you about this. So there is right now till now we have seen there are different random names given to all these. Okay, a random name given to all these containers. So how can we do that? How can we make it like custom? There we can do that as well. Suppose I didn't go, docker run, yeah, rm means if the container gets stopped, then it will be deleted itself. I'm not sure if it will work with let's just try it out if this detach mode. Okay, so name my CentOS, or just say 11 CentOS image. This is the image name CentOS. Okay, docker ps-a, yeah, it is running right now. Okay, what does this name will help us with? We don't have to check for every time for we don't have to check every time for the id. Okay, we can directly get the name and sudo docker exec -it, then day 11 CentOS. I could have copied it. That was also exec oh sorry, exec we already have provided, then bash. We got into the terminal. Okay, here we are in the CentOS machine. Who am I am root. What is my host name? So it is the id of my container. Okay, that is all. And if I check IP address, so this IP loopback, this is it goes to loopback. Why is it going to loopback? It is a local one. Yeah, this IP. So it is /16. Yeah. So this is the IP, and where have we seen this the same IP? First of all, I just exit from it. How can I exit from here? It is just as simple as that. Control D. Okay, press Control D, and you can exit from the container. Still the container is active. Okay, and if you want to, there is I think Control D. Yeah, Control D for exit. So here we are. Yeah, so here we have created this container. Okay, now let's just inspect this. Sudo docker inspect display total size type, inspect the container. So this is the docker container that we have, and here we go. Okay, so what do we find here? So this is the IP, this is the gateway. Okay, and if I just check, if I ifconfig, so here you can see this is the gateway, and here is the virtual host virtual NIC that is created for that particular container. Okay, so if I just let me just remove that container, rm-f, f for forcefully removal, because the container is running 11. I think keep it short and sweet. Okay, so we have created this we are again creating this container. Okay, then sudo docker exec if day 11 bash. So here we are, we have created this particular container. If we check IP header, so here you might be seeing this. Yes, this is the IP of that container. Okay, and so yeah, here you can see if I want to update yum install Apache, so it will check and install the Apache server in this. Failed download metadata. Yum update, I think update we need to run fast. Google.com. Internet is connected. I think there is something with something wrong with this. So don't worry, we can anyhow check another container itself. So this is how we have checked the container and container network. So right now it can access the network here. I'm just removing this container also. Let's just install right now. Nginx is not installed in my system. Okay, let's just install Nginx. So how would I install it? Sudo docker run. Okay, run. There is one more command right now. If I have to check docker, sudo docker image. Okay, images. So I have busybox and CentOS downloaded, but Nginx is not available. Okay, so how would I install? How would I check image -h? So image, we have image build, image history, image import, inspect, load, ls, image ls is actually images is extended to image ls, then image rm, save, tag, push, pull. So what we can do here is there is docker pull command, docker pull, and it is similar to docker image pull. Okay, docker pull Nginx, and where is it pulling? Okay, there is one file in it. Let me just show you. ls, I think docker. Yeah, So we have sudo docker pull nginx. Okay, docker pull pull nginx. So it is to download the image, okay, container image into our system. So we have downloaded it. We have run it using this command, uh, sudo docker run -dit. This rm tag is provided so that as soon as the container is stopped, it will be deleted. Then this -p is for port. So we have exposed it on port 80. This is host port and this is container port. Okay, and here we can access it. Suppose if I have to add some kind of index.html in that particular location, so there is one more command, sudo docker like cp hyphen docker to copy command. Then I think we have yesterday or day before yesterday we have copied it, uh, where www html, yeah, where www html will be copying it into. Okay, so here are these, what is plugins, volume, local, bridge, host, IP VLAN, Mac VLAN, null, overlay. So these are the network types that are available. So bridge, host, IP VLAN, Mac, null, overlay. So we'll discuss. Currently we are using the bridge type, which allows us to. Then there are AWS logs 20. So these are the plugins. Swarm is inactive. Swarm is, so then there is, I think, registry. There is one thing called registry. Docker root directory. Yeah, this is the Docker root directory. Here all the data is saved. CPU 2, memory 4 GB, OS type Linux, kernel this, Ubuntu. Where is the registry? I want to see the registry. Container version, run C version, init version. No issues with that. Sudo etc docker. There is one file where we can check. Let me just check. There is one command, I think, docker info mission denied. Yeah, docker info is one of the command that is basically tells about everything, like this is the version, context set to default, and server version, this overlay storage overlay 2 is where the data, the files of the containers are stored. Okay, this is overlay 2. History is not configured right now, no worries with that. Container default runtime, run C swarm. And what is the file? I think in here we have seen. So this is the docker hub where all the files, all the container images resides. It provides a docker hub is a registry service. Okay, a remote registry. So here is all the info that is available for your docker runtime. Okay, docker engine. This is how it is. So I think this is all for today. We can continue from here on. Right now, yeah, one thing that is left is sudo docker. I just want to go to nginx. This is the nginx file, nginx container. There is this default location where we have to put, yes, user share nginx html. Okay, nginx. Okay, so where from where is it pulling nginx? I think there is one more. Let me just check. User share. Okay, successfully copied. Let's just see if I can. Yes, it loads. Okay, so this is how we can run our container and copy files to and from the container. So let's just see about what we have learned so far today. So we have learned about the containerization, what is Docker, what is the difference between containerization and virtualization, how is Docker currently working. There are other containerization tools, like runc is one of them. Runc is directly used by Kubernetes for container runtime, and there is there are other things as well. This Docker CLI and Docker daemon has been deprecated from Kubernetes, these part. Okay, so yeah. And one more thing is, yeah, how containerization and virtualization are different from each other. Let me just explain you one more thing about it. Wait, 1 minute. So we already know that virtualization virtualizes the hardware, while containerization virtualizes the OS. Both of them are this virtualization technologies. Okay, however, for I have prepared something. Actually, here is this file. Yeah, docker, nothing in this file. No worries, I think it is not initiated right now, but there is this file we can create. So right now I think we'll check tomorrow on how to configure the remote host. In fact, I just show you the remote host with it, which is currently configured. hub.docker, okay, docker.com. Okay, so this is the remote directory that is currently linked with the Docker container. Let's put it like Okay. So here are some of the points that differentiate between virtualization and containerization. So containerization is packages app and dependencies into a container. Okay, it only packages a particular application or software, however creates a virtual machine running full of OS instance. Okay, it has all the functionality. Virtualization has all the functionality of an OS. Here this is the definition of containerization. Mostly containerization virtualizes operating system. Virtualizes this whole hardware. Performance is containers are very lightweight and fast. Virtualization is heavier due to full OS emulation. Okay, it replicates a complete OS, complete operating system. Okay, complete hardware itself. Isolation level here in containerization is process level isolation. Okay, however in virtualization it is complete isolation. For it also has separate kernel. However in containerization it actually, no worries with that. So isolation is it is only provides process level isolation, and this virtualization provides kernel complete isolation. So in containerization, containers share the kernel of the operating system. Okay, we have discussed about it. So suppose this is our, so there are two major components of a particular operating system. Let's just say this is our container, this is our shell, this is the shell, and this is the kernel. Okay, shell interacts with the user, however kernel interacts with the with the hardware. Okay, this is how shell and kernel works. So what happens is container directly share the kernel. Okay, they just create a virtual shell. They just no fill. Okay, so they just create a virtual shell over here on top of this kernel, and then they run. So you can see all the process can be seen in our host machine. Okay, the container processes are seen in the host machine. However in virtualization, only in host machine can only see the hypervisor it is running. Okay, not the virtual machine log.